how to use Git. So what is Git in general? It's version control, so that you can keep track of all the changes you was doing in your project, and if there's something going wrong, you can also switch back to earlier checkpoints, for example. So you can't basically break your project anymore if you're using Git right. And you can also use Git for team collaboration because you can use collaboration on the same project using GitHub, for example, remote. And it's also a platform for sharing your code with everyone out there, open source, also closed projects as a team. So it's a really powerful tool. And we wanted to introduce to you really easy way to get started with GitHub. And for that, we definitely recommend GitHub Desktop. But there's also additional applications available for GitHub. For example, you can use the terminal for that using CLI. You can use integrations directly in VS Code, for example. So there's a lot of tools available, but we just showed today as an example in GitHub Desktop. And yeah, it's really user-friendly. You will see that you don't need to learn any of the commands by yourself. You can just use easy-to-use user interfaces in the application, and it works on any platform. And yeah. So just before you get started with all of that, just as a team, decide on what exact Unity version you want to use, and as well which Meta SDK you, for example, want to use. And it's always a good idea to define someone in the team who is taking care of the GitHub itself, setting up the project, and also is maybe responsible for merging different branches later. What it exactly means, we will show you. And yeah, about GitHub itself, you can create a free account on the platform. I will show you the platform in a second. And then the only thing you need to do is downloading the GitHub desktop application and logging into that. And here's, yeah, just an example of how to use it. I will show you the GitHub platform shortly. So actually, this is GitHub. You have a profile probably here on the page. This is my page. And you can have repositories, which basically is just a different term for a project, which you have. Just as an example, we have here the Meta PCA Roboflow project, which we can go into. And we see we have a overview here. You can share text, pictures, images, videos with your users, instructions of how to set up your project. And you see that you have all the files in here, which is part of your application. And what's interesting is that you can also see the history of what was done. For example, in this project, I was submitting a new change yesterday, and you can also go into history and see what exactly got changed in here. And yeah, how to set up your own project. There's two ways. You can set up your own project in here under repositories in GitHub. You can just create a new project here and fill out some of the properties and create a repository directly remotely here on GitHub. The alternative would be that you can use the GitHub desktop application, which you just installed, and you create a project first locally on your computer. So for that, you would just go in the application to new repository, and you just choose a name. I call it test workshop, and you can give a description. I just write in here description first. You can say at which location it should be created. If you want to add a README to it, which is the description file we were seeing on the GitHub page, the main page. And important is here, if you want to use it for Unity, to also choose the gitignore file for Unity. A gitignore file is just like a basic text file, which includes the description of all the different files in the project, which will not be part of the tracking of GitHub. So it will be not uploaded to GitHub because they include maybe security related data, or it's maybe big asset files, which will be anyway automatically download from the internet, for example, and things like that. Everything you don't want to push, you can put in the gitignore, and here it will automatically create one for you for Unity. You can also use a software license for it. I will not choose that now, and I just create a local repository now. Now you can see I'm currently in this test workshop repository, and I can see the changes I did. Right now, there's no changes. I can see history. No real history. There's just one thing, which is the initial commit of setting up the project. You see there was 3 files added here, and we are currently in the main branch. What the branches I will show you in the presentation later again, but we are just in the main part of the repository right now, and that's basically everything you can see here. If we now go back to our presentation, you can see some guidelines you need to think about if you want to push your project later from local to GitHub itself. And it means like take care of that your descriptions, for example, or messages make sense and give details about what was it about, so that your team colleagues can understand what you was putting in there. Do push your changes to the GitHub remote repository as regular as possible, and yeah, do it really regularly. Because of that, or with that, you can yeah, you probably will have less problems of later merging everything together, which you was creating and your colleagues was creating, your teammates was creating. And also avoid including big files, probably files bigger than 100 megabyte. For example, take care of that big 3D models, videos, etc. will be not in your project. And if they are in your project, try to put them into the gitignore file I was already mentioning, because this type of files should not be inside of your Git repository. Because the Git repository is more like for small text-based files, for example, which like code files, but no binaries or media files. And yeah, if you was doing something wrong, like we already mentioned, it's no problem. You can always reset the to a checkpoint before, or revert it to a checkpoint before. But also that I will show you one time in the application after we was creating something. And this one is maybe a good example. So how would it work? So basically, this yeah, the main thing, this structure in GitHub is organized by branches. And this one, for example, is now the main branch. We already know it because we had it in the application itself, right? In the GitHub desktop application, there was the main branch and we already had it. And if you now want to make a change to this main code, the way of how you would do it is you create a new branch, which is now your work, or maybe a feature you want to work on. And when you work on it in this branch with multiple small changes, and at some point you want to go back and input your work into the main branch, which will be the running application which your team is working on. And you was just creating like one feature on it and want to bring it back. And maybe during that time, someone else also checked out or created a new branch on this main from the main and was working on his features and also later want to merge it. And how that would look like, I will show you one time in the application. So you see, we still just have this main branch, and we can even look here into the branch or the project itself. You see that's all the files which is in here, which was automatically generated. And if, for example, now I would create a text file here and I call it main text file, then if we go back here, we see, oh, there's a change, there's a new file, main text in the main branch. If I now would change something in here, I would say main. Then I go here back and I see, oh, someone added something, the text main, for example. What could be now? I say like, okay, that's all I wanted to add to the main branch. That's how I want to also share it with my colleagues or my teammates. Then what you can do is committing to these changes, saying, okay, that's exactly what I want to do. You can write a commit message and a description. You can also ask GitHub Copilot to do that for you. And then you just commit this change. And now you see there's no changes left here because we are now inside of this branch, let's say. And you can also see it in history. Before it was just this initial commit. Now it's this, it's inside of the branch, let's say. And you can also still see this text file here. It's still in here. What we now could do is we can create a different branch because maybe I want to work on a different feature. And I don't want to directly change things in main branch because I want to work with other people on the project. So everyone maybe wants to work on their own branch and later we put it together again. So what I would now do is creating a new branch. Here he's saying, oh, you are actually right now in the main branch. So he will create this branch from the main branch. So I call it feature one, which I'm working on. And now I created a new branch. It's called feature one. If we now watch into our project again, nothing changed. There's still this main file, which was creating because it was already committed to the main branch. But we are now in feature one branch. So if we, for example, would now add in here a file which is called feature one, and we maybe add also some text to it, feature one text, then we would now see in this branch, there's a new change, a new file was created, the text feature one text. And if we go now back into the main branch, I just leave my changes on feature one. Then if I go back now to our project here, the file is gone. Because we're in the main branch, the files still don't exist here. Yeah, that's how we can take care of not submitting every small tryout, let's say, into our main application. So let's say someone else is now also in the main branch and they also want to add a change. So we could do that. We are now creating a new branch from main again, which is called feature two. Now we have a branch feature two. It actually looked in the Explorer. Same than in main, because we was creating it from main. There's no feature one file in here right now. So what we could now do here in the feature two branch is we create a fixed file called feature two. We change text to feature two text and create it. And what we now see, there's the change. Everything like expected, like we already saw before. We have a new file here. And if we go back to main, we switch to branch, leave the changes here. Nothing happened in main. Our file is gone again. So what we could now do is we are now somewhere here, like the main branch is right now still untouched. We have two branches going away from the main branch. But at some point we are like, okay, that looks good. Maybe we should bring it back into the main branch. So I would go here now again into the current in the feature one branch. I see, oh, here's some changes I was adding. I want to restore them. I want to see what they were, And now I still have this change here. And what I can do is I can first commit these changes to the feature one branch because I didn't do before, which means, okay, feature one branch should keep the changes. Now you see there's no changes anymore. It's in the history. It's added. Feature one branch. It's in here in the folder. So now I maybe want to decide to revert these changes. Like I don't want this file in there anymore. So I could also revert it really easily here. This feature one text is not there anymore. And like you can see, it's gone. Now I can revert, and add this file here again. And it would be back in our folder repository. So let's come back to the main point. I have this change now in here, which I committed already to the feature branch, but I want now to put it into the main branch, which is right now empty. There's no feature one and feature two. So I go into the main branch. I say, choose a branch to merge into main. And here I could now choose feature one or two. Feature one I can do because I was committing something. Feature two I can't because I didn't commit my changes there. So I would just start with feature one first. You see it worked. So we are in main, and in main now is available feature one. If I go now back to feature two, you see the changes are just stashed here. I didn't commit them to the history. There's no feature one in the history. So first I need to restore the changes if I change back here. And now I need to commit them to the branch, to feature two branch, to have them in here. And if I now go back to main, I can now also choose feature two branch to merge it into the main branch. And now in the main branch, there should be available both features, both changes I was doing. Now that's the really nice case. You as a team was deciding on, okay, a person one is working on this features and he's just touching this specific files, feature one, and the other person doesn't touch the same files. He works on feature two, which is just needing this file. But what would happen if what would happen if we both work on the same files and want to merge it back? And that's actually something you should try to avoid as often as possible, because that will lead you into merge conflicts. You can get rid of this conflict, but it can be sometimes quite complicated, especially in Unity. And just imagine for understanding this merge conflicts, you have a white cube over here, or one shared file, and someone is working in this root branch, and someone is creating a child branch of it and is also working on the same object. Someone changes the color to red, someone changing it to blue, and then you merge it together. And yeah, what would it be like? Would the color of the cube will be red then? Would it be blue? Actually, it can be any of them, and that's what I said. It can be quite complicated. So there's easy problems. For example, if you have a text file, then actually these conflicts would be marked automatically using this uh, signs, for example. In Unity, it could be a really, really big problem if you was maybe working both two people on the same scene and want to merge it together, because scenes have a quite complicated file format, I would say, at least compared to normal text files. So it's really hard to decide then on what to keep, on what to not keep. So yeah, don't do that with scenes. And I just show you an example also how this merge conflict can look like. So we again have these two branches here open, feature one and feature two. So I'm now changing to feature one, and I will create change the main file. I would just say here, oh, here I put some parts of feature one into the main file. I save it. I see here, oh, there was something added, something minus, and then someone else is in feature two. And for him, it was also looking like this empty file. So he was like, oh, maybe I can add here before a bit of feature one and do this changes here. Oh, now we're in feature two, right? So I put some changes here. And now if I just go back to the other one, in both cases, I maybe commit the changes now to the branch itself, no problem, because we are still in our feature branch one. Someone else was in feature branch two. He's just also committing his changes to the branch itself, no problem. But now someone is responsible for putting this all together in the main application, which is in the main branch. And he now see like, oh, I first, oh, I first want to put in feature one into the application. No problem, feature one. I will look into the main. No problem, we have feature one in here. Actually, I think I just put time the text feature one, but it doesn't matter. And now he would say, okay, now I put the second feature into the application. So I am staying in main. I will put feature two in. And you already see here, oh, there will be a conflicted file when merging feature two into main. What does it mean? Two people was working on the same file, and it's quite complicated to understand that. So now, at least in GitHub Desktop, it's quite easy to see. They are offering us now to open this file in Visual Studio Code. And I need to close this here one time. You can see there's the both changes in here. And now it gets complicated. You need to decide like, do you want to just keep the old change? Do you want to accept the current change? Do you want to keep both? In this case, I want to keep both. So I accept it. And it looked like here, even there's already a problem. He's putting in two-time main. I will just save it like this. And now I go back to GitHub Desktop. There's no conflicts anymore. So now I'm able to merge it. And if I'm now in the main branch and I watch into our project again, you can see it's working. But even in this really simple case of a text file, you see it was already complicated. It was just one file. Imagine it's like maybe like 30 files over the time, maybe 40 files in your project, long files, a lot of changes. This merge conflicts can really give a lot of work to you. So the easiest way to avoid it is really just communicating a lot with your team, avoid working on the same files together, just yeah, have some communication with your team on who is working on which parts of your project, which files. Uh, if you want to work in scenes, then maybe create multiple duplicates of your scenes so everyone can work in a different scene, because that scene it will get really crazy or really tough, difficult to work on this merge conflicts. And an alternative for that would be you can have one scene and have fixed prefabs in the scenes, and then everyone is just working on a different prefab of objects for that scene. That's also a common way of working at the same time at the same scene without really touching the scene. And yeah, just try to merge regularly and avoid any of these merge conflicts. And yeah, that's actually it. That's also my main message. Avoid merge conflicts and communicate.